intelligent life on other planets.
Other intelligent life in the universe.
We see evidence of life.
The James Webb Space Telescope cost $10 billion and consumed countless person-hours. It's also the most complex and powerful space telescope ever built by humans, so expectations are high for this brand new eye in deep space. One of these expectations is what scientists have been grappling with for ages. Is there life elsewhere in the universe? Are there aliens there waiting to contact us? One of the areas the James Webb Space Telescope may find aliens or life signals is Haitian planets. Can the new Space Telescope find life out there? Join us as we dive into how the new James Webb Space Telescope will discover alien life. Few space missions have taxed NASA and the whole space scientific community as much as the James Webb Telescope. With a cost that ended up being 10 times the original budget and multiple delays, including the new cancellation of the program by the Senate, everybody involved breathed a half sigh of relief, if there is anything like that. Everything about the JWST was complex, yet the team launching it had only one shot at getting it right. This was because it would be situated where it was impossible to send a repair mission 1 million miles away from the Earth at a place known as the Lagrange 2 point. That orbit is unique because it lets the telescope stay in line with the Earth as it moves around the Sun. This allows the satellite's large sun shield to protect the telescope from the light and heat of the Sun, Earth, and Moon. JWST primarily observes infrared light, which can sometimes be felt as heat. Because the telescope will observe the faint infrared signals of very distant objects, it needs to be shielded from any bright, hot sources, including from the satellite itself. The sun shield serves to separate the sensitive mirrors and instruments from not only the Sun, Earth, and Moon, but also the spacecraft bus. To get an idea of the heat shield, the temperature difference between the hot and cold sides of the telescope is enormous. You could almost boil water on the hot side and freeze nitrogen on the chilly side. The telescope will operate at about 225 degrees below 0 Celsius, minus 370 Fahrenheit. To have the sun shield be effective protection, it gives the telescope the equivalent of SPF 1 million sunscreen against the light and heat of the Sun, Earth, Moon. These bodies all have to be located in the same direction. The JWST spent the first day after launch executing the first and most crucial trajectory correction maneuver using small rocket engines aboard the telescope itself. It also released and deployed the high-gain antenna to enable the highest available data communication rates as early as possible. During the first week, the JWST executed a second trajectory correction maneuver and began the sequence of significant deployments, beginning with the fore and aft sunshield pallets. The next step was separating the spacecraft bus and telescope by extending the telescoping tower between them. The tower extended about 2 meters and had to be extended so that the rest of the sunshield deployment could proceed. Next, the sunshield membranes were unpinned and the telescoping sunshield mid-booms extended, pulling the membranes out with them. The last step in the sunshield deployment was tensioning of the membranes. In the meantime, other things like radiators were released and deployed. JWST finished deploying the telescope structures during the second week by unfolding and latching the secondary mirror tripod and rotating and latching the 2 primary mirror wings. And near the end of the first month, it executed the last mid-course maneuver to insert it into the optimum orbit around L2. The various scientific instruments were also powered up. Kudos to the launch team because due to the flawlessness of the process, the service life of the Space Telescope has been extended. Previously, NASA expected the fuel in the telescope to last about 10 years, but thanks to the efficiency of the launch, the mission can now extend to 20 years of taking breathtaking photos of the most distant places in the universe. However, before the photos start to flood in, the JWST will still go through months of fine-tuning the individual components. Using the Fine Guidance Sensor, the JWST will point to a single bright star and demonstrate that the observatory can acquire and lock onto targets, and will then take data mainly with NearCam. But because the primary mirror segments have yet to be aligned to work as a single mirror, the JWST will obtain up to 18 distorted images of the same single target star. NASA will then embark on the long process of aligning all the telescope optics, beginning with identifying which primary mirror segment goes with which image by moving each segment one at a time, and ending a few months later with all the segments aligned as one. Cooldown will effectively end, and the cryocooler will start running at its lowest temperature, and MIRI can start taking good data too. This step will be followed by calibration and completion of commissioning, after which scientists will take their turns to use the telescope to study the universe. You can see why expectations are high for the JWST. It will peer billions of years back in an effort to answer the questions of how we got here and why we're here. However, in between those goals, this powerful telescope will attempt to find the evidence of life in deep space. Who knows, we might find aliens. One of the places the JWST will look into to find evidence of life is the Haitian planets. What are Haitian planets, and why do astronomers suspect they may host life? To understand Haitians, you need to know about exoplanets. These are planets that are not in our solar system, but are revolving around their own sun. Astronomers suspect there are billions of exoplanets in deep space. However, these exoplanets are notoriously tricky to spot because the stars they orbit outshine them. To date, about 4,000 exoplanets have been identified outside of our solar system. Scientists have looked into exoplanets to see if life can exist there. When evaluating exoplanets for whether they can host life, scientists look at whether they are located within the habitable zone around the stars they orbit. This zone is a sweet spot, meaning the planet is at the right distance from the star for liquid water to have a stable presence on the planet and possibly support life as we know it. But now scientists are looking at a specific class of exoplanets, Haitians. Haitian planets are hot planets covered in oceans with an atmosphere rich in hydrogen, and they are much easier to find and observe than twins of our planet. We do not have any Haitian planets in our solar system. Some of the Haitian planets are bigger and hotter than our planet, but researchers believe these planets have large oceans that could support the kind of life that began on early Earth and can still be found in extreme ocean environments. One of the most appealing features of these planets is the fact that they have a larger habitable zone than Earth or Earth-like planets, so they could still support life even though they exist outside of the zone where our planet is required to be in order to sustain habitability. Of the thousands of exoplanets discovered within the last 30 years, many of them are between the size of Earth and Neptune. Scientists use names like super-Earths and mini-Neptunes to describe these planets, which can be rocky like Earth or ice giants like Neptune, or exist somewhere between. Mini-Neptunes are more than 1.5 times the size of our planets. They are still smaller than Neptune, but too large to have a rocky interior like Earth. And beneath their atmospheres, which are rich in hydrogen, the pressure and temperature are likely too great for life to survive. However, thanks to recent research by Niku Madhusudan and his colleagues, we now know that this inhospitable nature isn't always the case. Depending on the conditions, including size, mass, and temperature, some of these planets could be habitable. Their study is what led to the new classification of Haitian planets. These planets can reach up to 2.6 times the size of Earth and reach atmospheric temperatures of almost 392 degrees Fahrenheit or 200 degrees Celsius. Underneath their hydrogen-rich atmosphere are oceans that span the planet, and microbial life could exist in these oceans. Some of these planets may be tidally locked, a term that means they permanently have a side that receives daylight from the star it orbits, and the other side is perpetually in the dark, like our own moon. In this case, tidally locked Haitian planets may only be habitable on one side. Haitian planets are common among the range of known exoplanets, but they haven't been studied as much as super-Earths. Perhaps the answer to where life exists outside of our solar system has been within this known range the entire time. To determine if a planet within the habitable zone has the right ingredients for life, scientists search for biosignatures like oxygen, methane, nitrous oxide, and ozone, or biomarkers including methyl chloride and dimethyl sulfide, all of which are found on Earth. However, when looking for these various molecular signatures, scientists have been focusing on planets similar to Earth, which kind of makes sense as a place to start. But Haitian planets offer a better chance of finding several trace biosignatures. One example of Haitian planets is K2-18b, which is described as a mini Neptune or a super-Earth. The exoplanet orbits its star, the red dwarf K2-18, located some 124 light-years from Earth, and was first discovered in 2015 through the Kepler Space Telescope. K2-18b has a mass of about 8.92 times compared to Earth. Initially described as a potentially rocky world, two independent studies in 2019 used data from the Kepler Space Telescope, the Hubble Space Telescope, and the now retired Spitzer Space Telescope to confirm that it did indeed have a rocky core. The studies revealed that this exoplanet is a water world with vast amounts of water vapor in the atmosphere. One of the studies, published in the September 2019 Nature Astronomy, notes that K2-18b offers an unprecedented opportunity to gain insight into the composition and climate of habitable zone planets. While K2-18b has been described as a mini Neptune and now as a Haitian planet, Madhusudan said that most mini Neptunes are not in that newly coined category of planets because they are too big or too hot. This is why the Haitian planets straddle the boundary between super-Earths and mini Neptunes. There is more to be studied about Haitians and their possible status as hosts of life. With the JWST, scientists can now stare better at these exoplanets, most likely starting with K2-18b. Do you think JWST will find life in outer space? Let's hear your thoughts in the comments section below.